Hello, everyone. My name is Lan. I'm a software engineer inside of Amazon Machine Learning, and I'm also the co-author of this DeepDraw library. So let's go ahead with the next slide. Yeah, so basically, let's try to answer the first questions. What is DeepDraw library? DeepDraw library is a machine learning framework that's been designed and implemented inside of Java. It has most of the machine learning features, including the training and inference. It also has the Java features, including the multi-threading support and also the built-in memory control mechanism. And DeepDraw library has been designed into the engine agnostic way, where you can just like the definition for Java, write once and run anywhere. It can leverage on top of different deep learning frameworks such as MXNet, PyTorch, and TensorFlow. It's been benefited by its unified API, where you can leverage that directly, and it's very easy and very easy to understand. And it has surprisingly same behaviors while you're trying to use the same API while you're trying to leverage with different deep learning engines. And for a quick example, if you want to try to run inference on a PyTorch model with the same configuration, you can easily switch into another deep learning engine. For example, you want to run the similar models with TensorFlow, you basically don't have to change much of the code, and all you need to do is change your own dependencies. Another feature that DeepDraw library have is the model zoo support. It contains more than 70 different pre-trained models where you can use them directly for your own inference and training tasks. And currently, the source of the models came from different parts. Some of them came from the Gluon CV model zoo. You can also import from Hugging Face, Keras, and also Torch Hub, because thanks to the different support of deep learning engine. And the reason why we presented DeepDraw library is throughout the contribution with the different deep learning framework inside of Amazon. We're actively contributing to TensorFlow, NumPy, MXN, and PyTorch, and also many more different machine learning frameworks. From the experiences into this kind of the open source contribution, we gradually learn and understand what are the bottleneck for the machine learning and deep learning in the production needs. So that's why we're trying to invent DeepDraw library here to solve the problem. Okay. Next slide. So DeepDraw library is designed to be very simple, which means you can use them directly, even if you really don't have much of the machine learning or deep learning knowledges. And just saying this part, DeepDraw library has the model zoo support, contains a different model where you can actually apply them that directly by creating a very simple pre-processing and post-processing stage. On the left-hand side is actually a doodle draw recognition application. This is a model that can actually recognize the doodle drawn by different people, like the rabbit you can actually see on the left-hand side. And below that is actually an image classification that's implemented inside the PyTorch and running on top of the Android device. You can also run this in your PC device. And for the core inference code of these applications, it's only less than 20 lines of code. So it's very easy to integrate. And it has the same behavior while you're trying to run inside of the Android device or a PC platform. They have the same API and also same level of support. Yeah, next slide. So, and before we actually go into the benefit part, let's try to firstly understand why you should try to leverage DeepDraw library here. The first part is because it's very Java friendly. The initial reason why DeepDraw library came into part because there are actually teams in Amazon finding it really hard to integrate their machine learning models into their existing serving platform, mostly done inside of Java. They have to choose like two ways to go. First one, they have to maybe maintain some kind of GNI in order to call the C API from different deep learning engine, or they will have to end up writing the Python process in order to call the Python package for this machine learning and different deep learning product. It costs the things is running slow inside of their server, and also it's hard to maintain the packages because there are random crashes happen when they want to launch the different services. And the second reason is because the Java community really lacks a deep learning standard in most of the cases. While you're trying to leverage like different machine learning or different deep learning package inside of Java, you will find it really hard for you to find them have the consistent input and output between different packages. So Deep Java library trying to maintain a single standard, such as very similar to NumPy as most of the currently deep learning framework choice. So which means you will have seamless experiences from end-to-end deployment, no matter in training and inference, and no matter which kind of different deep learning engine you're going to use, they will all have the same experiences. And the final reason is because Java itself is really easy to understand and is very reliable during your service code. Especially you would like to have the good error handling and as well as the really good understanding while trying to integrate that piece of code. And Deep Java library is a natural fit since it's been designed in Java and also has all the Java standard features for error handling. Yep. Next slide. Yeah, and let's talk about the key advantage of Deep Java library. Firstly, it's very easy to set up. In just 10 lines of inference setup, you can have your whole inference work done in your process system. And it has a very small dependency requirement. For example, if you're trying to leverage TensorFlow CPU, it will only cost around like 200 megs of the disk space. And also in a total of only 3 packages you're going to import. And it's very fast. It can get up to 2 times performance boost on small model inference. And the term of the small model here means the model with less of the features. For example, if we have a SqueezeNet, we have benchmark SqueezeNet, it can get up to do 2 to 5 times performance boost on an inference server. And this kind of technology has been used widely by Amazon Ads and Query Understanding team to leverage with the service that has a really tight latency requirements. And the Deep Java library has also been applied into a very large scale. We have teams running Deep Java library with Apache Spark on a very, very huge data set, more than 800 million data set, and it can do the offline distributed inference in just 6 hours. And the Deep Java library also support for online streaming. That's also thanks to Java because most of this kind of package are implemented in Java. So Deep Java library can be a really easy integration, like a middleware to do some machine learning and deep learning tasks. And DJL is also very stable. It ensures like 100%, 100 hours benchmark test in every of our different version, which we make calls into the inference server all the time to ensure it won't crash. And next slide. In order to get the Java developer closer to Deep Java library, we actually implemented the 2 amazing tools. One is the JShell on the left-hand side, where you can just type in the Java code directly through all the terminal style stuff. And on the right-hand side, we created some toolkit where you can just put your inference code on the right-hand side and run the live inference. And also using different deep learning engine, you can switch between MXN, PyTorch, TensorFlow. And after this part is done, you can just grab the template and run everything locally. And these are all available from our website. Yeah. And finally, next slide. Deep Java library has the support for training. It has the MXN and PyTorch engine support for the training. And it has most of the data set and the models for CV and NLP work. And you can run your training work easily with Deep Java library. And finally, Deep Java library has another part of the advantage where you can just leverage all your code inside the Jupyter notebook, which is known mostly in the data science world, that you can quickly prototyping your model training and inference tasks in just one file without configuring the environment.